Okay, so we're given this circuit and we're required to find the voltage across R load, right, and the current through R load. So yeah, so you can use Thevenin's theorem for this question, right? And to do so, we treat the blue area, right, the blue part of the circuit as the part that we're going to perform Thevenin's theorem on. So by Thevenin's theorem, right, by his theorem, he claims that we can replace this part, the blue circuit, with just a single voltage source and a single current and a single resistor. So he claims that we can replace it like this, and this voltage, right, which we currently don't know yet, right, is going to be called the Thevenin voltage, VTH, right, TH for Thevenin, and the resistance is called the Thevenin resistance. So we don't know how to calculate the Thevenin voltage and Thevenin resistance yet. Sorry, we don't know what the values are, but we're going to calculate the value, we're going to calculate them using Thevenin's theorem. So to find the voltage, right, we're going to first disconnect the load. So A and B is going to be left as an open circuit, and then we draw the rest of the circuit. Right, so we draw the rest of the circuit, and now we need to find the potential difference across AB. So 82K, yeah. Now we need to find the potential difference across AB, and by Thevenin's theorem, the Thevenin voltage will be the potential difference between AB. So now, yeah. So to calculate that, we can use the voltage divider formula, right? Because your 1K is the resistor, your 1K is in this series circuit, and your VAB is the potential across 1K. So you can take 1K over 1K plus 82K plus 20K. So the denominator is the total resistance. The numerator is the one we're interested in finding the potential across, and we take 10 volts. So this is going to be 10 out of 103, which is approximately, if we put it into our calculator, we approximately get we get 0.09708. Okay, and that's to 5 decimal places. So that's approximately. Okay, so now that's our Thevenin voltage. We found the Thevenin voltage. The next step is to find the Thevenin resistance. So to find RTH, right? First of all, we disconnect AB, we disconnect the load from AB again. But this time, on top of that, we are going to remove the battery as well. So what does it mean to remove? It means to remove the effects of the battery, which means that instead of having 10 volts across these two ends, we are going to remove the effects of the battery, which is 0 volts, which means that we make 10 volts down to 0 volts, right? And to do so, that means that we connect it up with a wire. So by short circuiting across the battery, or rather by replacing the battery with a short circuit, right, we are removing the effects of the battery. So RTH is then equals to, by Thevenin's theorem, it's going to be equals to the effective resistance between A and B now, right, viewed from the external, and that equals to your 1K resistor in parallel with your 82K plus 20K, right? Because these two are in series. So to calculate that, we just use this, right? At 82K plus 20K, that gives you 102K, and this will give you, if we plug it into our calculator, that will give you around 990 ohms, right? Approximately 990 ohms. Okay, so yeah, so now we know our Thevenin voltage and Thevenin resistance. So this is around 990, and Thevenin voltage is around 0.09708. So now we can continue by now we can continue on to find the voltage across the R load. So VR load, right, by voltage divider principle, because your R load is in series with your Thevenin voltage, sorry, with Thevenin resistor. So it's going to be 10 over 10 plus 990 times 0.09708 volts. And that is going to give you, so that's going to give you um, that's going to give you 0.9708 millivolts. All right. And now to calculate the current through our load, we just need to take this and we take the voltage of the R load and we divide it by the resistance. So yeah, so we divide it by 10 ohms and that's going to give us 97.08 microampere. Okay, so that's how you calculate that's how you solve this question using Thevenin's theorem.